Alright, so these are at the top of 4.5 practice. In exercises 1 and 2, find the scale factor of the dilation and tell whether the dilation is a reduction or an enlargement. This is like an aerial view of two rectangles, not a square, two rectangles. Which of the rectangles is the original? The smaller one. We know that because it has just the letter P. Alright. What is the distance from the corner to point C? Is 9. So 9 corresponds with the smaller rectangle. Guys, I can talk, I promise. And then how far is the corner of the larger rectangle from point C? Is 27. So 27 corresponds with the larger, and then 9 corresponds with the smaller. We can first decide, is this going to be a reduction or an enlargement? Enlargement. Enlargement. So that means my scale factor should be greater than 1, right? You don't have to write that k is greater than 1, but it's just so you think through it. When we find the scale factor, it is going to be greater than 1. With a scale factor, do you add it to the side lengths? Do you subtract it? Do you multiply it or divide it? You multiply it. So the scale factor was multiplied times 9 to get the number 27. So what do I have to multiply times 9 to get 27? 3. So my scale factor is 3. Wonderful news. Question about this one. What would my scale factor be the other way? Like if I went from the larger to the smaller? It's 1/3. Yeah, always the reciprocal. All right, this next one, the original is the larger one. So is this a reduction or an enlargement? It's a reduction. So reduction. Oops. Which means k has to be less than 1, which means we need a number smaller than 1. All right, so how far is point P from point C? 10. So it was 10. All right, then it got multiplied times the scale factor. We don't know the scale factor, so I'm going to call it x. I'll show you this way and then remind you can do it in your head a little bit. All right, and then what did the new distance become with my, once I multiplied my scale factor? 4. So we're going to end up dividing 4 divided by 10, which reduces to 2/5. 2/5. So a lot of people just start dividing things. You want to make sure that your fraction makes sense. If you had 5/2, why would I know that 5/2 is not the answer? Because that's bigger than 1, which would make the shape get bigger. We want it smaller than 1, so it'd have to be the reciprocal of that. Okay, so questions on one of these? Wonderful news. We got a graphing question. Go ahead and draw an x and y axis. You don't have to count to the middle. Just do the best of your ability. So P is over 1, to the right 1, up 2. And then Q is to the right 2, up 2. R is to the right 4, down 2. And then S is to the left 1, down 3. Connect your dots. It's just a quadrilateral. Is this quadrilateral going to get larger or smaller? Larger. My scale factor is bigger than 1. So what do I do with my scale factor to find each of my new coordinates? Multiply. So 1 times 2, 2, 2 times 2, 4. And then Q prime, 2 times 2, obviously, 4, 4. R prime, 4 times 2, 8, and then negative 2 times 2, negative 4, And then last, s prime, negative 1 times 2, negative 2, negative 3 times 2, negative 6. So we are going to graph these to the right 2 up 1, 2, 3, 4. Make sure you're labeling p prime. Q is 4, 4, to the right 4, up 4. Q prime. R prime is to the right 8, down 4. And then S prime is to the left 2, down 6. Yep. They do overlap a little bit when you draw that way. What I ask you to do on your quiz and your test is to highlight the new one, or you can highlight them both different colors. Just makes it easier to see because there are a lot of lines. So go ahead and take a moment to highlight one of them, if not both. So you'll want a highlighter. I think I asked for 2 on your quiz. The last 2 things are word problems. You will see definitely on, I think it's even on your exam, if I remember correctly, a question that looks like this. You design a poster that is 8.5 inches by 11 inches for a contest at your school. The poster of the winner will be printed on a 34-inch by 44-inch canvas displayed. What is the scale factor? So each of these in the original, so we have 8.5 by 11, they correspond with a different length in the bigger poster. What does 8.5 inches correspond with? 34. And then what does 11 inches correspond with? With 44. So which of these is easier to work with? The second one, 11 and 44. So a scale factor, I would multiply 11 times something to get 44. So that number would be 4. So that means the scale factor is 4. And then the last, a biology book shows the image of an insect that is 10 times its actual size. So in the book, the bug is bigger than what it is in real life, right? So the image of the insect, so in the book, it is 8 centimeters long. So will the real life insect be bigger or smaller than that number? Smaller, okay, because remember the book is bigger. So what am I going to do to find the actual length of the insect? Divide. Which number goes first? 8 would have to go first. Because if I did 10 divided by 8, that would be over 1. And that would mean my real life insect would be bigger than what it is. We would do 8 divided by 10, which would mean it is 0.8 centimeters long in real life. So less than a centimeter. At this point, you could write on the back if you want. If you don't want to, that's fine. But that was 4.5. There are other things on there, like writing a rule and naming a vector component. When you write a rule, what is the first thing we write down? X and Y, and then an arrow, right? Then we have to explain what happened to the X and what happened to the Y's. So in this picture, which one is the original, the red or the blue? The red. So pick a letter, A, B, C. A sounds good. So we're going to find the shift from A to A prime. So horizontally, we go to the left 5. So what does it look like to go to the left 5? Subtract 5. And then what direction do we go? We go up, and it's up 3, so that would be plus 3. Just for practicing sake, it says write a component vector. What would this look like as a vector? Negative 5, 3. Yeah, that's it. So there are 2 different ways to write the same thing. They shifted to the left, and then they went up. The second, we're going to do the same thing. Which of these shapes is the original Is it red or blue? It is blue this time. So, from the blue, do you want to do A again? We're going to see how much it shifted from A to A prime. So, we went to the right, how many? 6. Is it 1, 2, 6, 7, 8? I think it's 8. So, plus 8 went to the right 8, and then went up, and then went up 4, which would be a plus 4 again. So your vector would be 8, 4. Questions on a graph like this? Okay. All right, describe the shift. What happens in this first one? Positive 8, positive 2. What does the positive 8 mean? To the right.
Please pardon the interruption.
And then positive 2 means up. Okay, negative 8, left, and then negative 2, down. All right, negative 3, left, and then plus 7, up, plus 3, right, and then negative 7 means down. Yeah. Okay, so good. You'll need to remember how to graph these. This is actually also on your midterm. I think it's 4 or 5 questions on your midterm. Okay, so y equals x. Does it touch one axis or both of them? Touches both of them. Where does it touch them? At the origin, right? Where they cross. And then what is the slope for y equals x? 1, positive 1. So it goes up 1 over 1, up 1 over 1. So it looks, like this. You would draw the dotted line. Y equals negative x. What is that one going to look like? Like the same thing, but negative. Yep, the other way. And again, you'd make it dotted. Y equals negative 3. Which axis does y equal negative 3 touch? The y at negative 3. So what is it going to look like? Horizontal. And then x equals negative 3 will hit x at negative 3, and it will look vertical. Questions on these? Make sure you're always graphing the line of reflection before you, math. That's it.